So, hi everyone. This is the last video in this series of videos on partial derivatives and higher order derivatives. So, yung topic natin for today is the second half of the title. We want to define what higher order partial derivatives are, and also we would like to be able to calculate them. Actually, madali lang naman yung concept ng higher order derivatives. So, kung meron kang function f of xy, you can differentiate that with respect to x, or you can differentiate that with respect to y. Pero in both cases, those are still functions of x and y. So, pwede mo pa rin silang i-differentiate with respect to x and with respect to y. So, halimbawa, yung fx, you can differentiate this with respect to x or with respect to y. Same with fy. So, you can differentiate this with respect to x or with respect to y. So, itong mga makukuha mo new functions na ito yung mga tinatawag na second order partial derivatives. Okay? So, analogous ito sa one variable case. So, sa one variable case, meron tayong f prime. So, that's the function. Okay? Pag dinifferentiate mo siya, so this is your derivative, f prime of x. Yung f prime, you can still differentiate that. So, makukuha mo ay second derivative, f double prime. Pero sa ating two variable case, meron na tayong apat na second order derivatives. So ganun lang siya. Simple lang yung idea. You just differentiate the partial derivatives. Ang nakakalito lang siguro dito yung notation. Halimbawa, yung process of differentiating fx with respect to x. Okay? Ito yung unang second partial derivative natin. Paano natin tatawagin yan? Okay? So, itong function na to, pwede nyo siyang tawagin na fxx. Okay? Bakit fxx? Kasi pwede nyo isipin na yung f sub x, no? So, yun yung function natin, yung partial derivative f sub x. Kinukuha natin yung derivative niya with respect to x. Tapos, para makatipid tayo ng parentheses, tatanggalin na lang natin siya. So, parehas lang yan. Okay? So, halimbawa, paano pag gusto nyo kunin yung partial derivative? So, what if you want to differentiate fx with respect to y? Ano yung notation na yan? So, itong second order partial derivative, how would we denote that? So, yung notation natin dyan ay fxy. So, from left to right, yun yung order ng pagdi-differentiate niya. And so on. So, halimbawa, yung fy, if you differentiate this with respect to x, ang notation na gagamitin natin, so we're differentiating fy with respect to x. So, ang notation natin ay fyx. And finally, yung huling second partial derivative natin. So, we want to differentiate fy with respect to y. So, yung notation natin ay fyy. Okay? So, ito siya. Yung nasa pangatlong column. Okay. Ngayon, ano naman itong mga nasa pangalawang column? Well, ganun din yung idea. So, halimbawa, for fxx, ang order natin dyan ay differentiate with respect to x, then with respect to x again, di ba? So, ito ay derivative with respect to x. That's a function. So, pag nilagyan mo siya ng symbol sa kaliwa, ibig sabihin, dinidifferentiate mo itong nasa loob with respect to x. Okay. So, ito halimbawa, anong ibig sabihin nito? So, you have a function z, tapos di-differentiate mo siya with respect to x. That's the first step. Okay. And then once you get this function, kunin mo na yung derivative niya with respect to y. So, that's the same as fxy. So, mapapansin niyo, pabaliktad na. Kung ito, from left to right yung pag-differentiate. Itong partial symbol, from right to left yung order. Okay? So, ano tong nasa second part? Itong nasa second column, ito lang yan. Pinasimple mo lang yung nasa first column. So, halimbawa dito, teka lang linisin ko lang. Okay. So, halimbawa dito sa first expression, pag tinanggal niyo yung parenthesis, pwede niyong isipin yung sa numerator may dalawang partial sign, so partial squared. Tapos sa denominator, meron kang dalawang partial x, kaya meron kang partial x squared. So, ganun lang. Yung nandito rin, partial squared z, kasi dalawang partial yan. Tapos dito, magiging partial y, partial x. Wag yung basta-basta pagbabalik rin to kasi yung order, then very specific na. So, halimbawa dito, ang ibig sabihin yan, you have to differentiate with respect to y first and then with respect to x. So, yun lang. Magkaiba kasi order niyan eh. Kapag nakasulat siya ng ganito, okay, from left to right yung order ng pagdi-differentiate. Pero pag nakasulat siya in the partial symbol sign, yung pag-differentiate mo ay from right up from right to left. Yeah. Okay. So para malinawan tayo, let's look at this particular example. Halimbawa, you have f of xy equals ln of 2x plus 3y. So pinapahanap sa una itong partial squared w over partial x partial y. So ang ibig sabihin niyan, uunahin niyo munang kunin yung partial derivative with respect to y. Again, from right to left pag ganito yung notation. So ito yung w natin. So if we differentiate this with respect to y, ang makukuha niyo ay 1 over 2x plus 3y times the derivative of this thing with respect to y. And that's 3. Okay? So, ang partial derivative natin ay 3 over 2x plus 3y. Again, meron tayong function of x and y. So, sabi dito, i-differentiate natin yan with respect to x. So, siguro makakatulong kung isusulat nyo to as 3 times 2x plus 3y to the minus 1. Okay? And then, let's try to differentiate that with respect to x. So, bababa yung exponent, di ba, magiging negative 3 times, and then subtract 1. So, magiging 2x plus 3y to the minus 2 na. And then by chain rule, you have to multiply by the derivative of the inside function with respect to x. No? So, times 2. So, pag sinimplify niyo yan, that's negative 6 over 2x plus 3y squared. So, ito yung ating partial squared w over partial x partial y. Similarly, dun sa part B, ang unang kukunin natin ay partial with respect to x. So, ano ang derivative ng w with respect to x? So, that's 1 over 2x plus 3y times the derivative of the inside with respect to x. So, that's times 2. So, meron tayong 2 over 2x plus 3y. And then, once you get that, para makuha mo yung second order derivative, i-differentiate naman natin yan with respect to y. Okay. So, again, rewriting that this is equal to 2 times 2x plus 3y to the minus 1. And then, pag dinifferentiate nyo, you get negative 2. No? Kasi bababa na siya ng negative 1. And then, the exponent, you have to subtract 1. Tapos, multiply by the derivative of the inside with respect to y. So, times 3. And ang lalabas ng sagot dyan ay negative 6 over 2x plus 3y squared. So, kung mapapansin nyo, parehas lang nakuha natin. Hindi nagmamatter kung una nyo siyang dinifferentiate with respect to y or with respect to x. And the reason for that is because we have the following theorem, which is called Clairaut's theorem. Sabi ng Clairaut's theorem, if you have a function where fxy and fyx are both continuous, so mahalaga tan. So kapag continuous ka on some region R, dapat yung fxy mo at fyx magkamukha lang. Hindi nagmamatter kung unahin mo siya i-differentiate with respect to x or kung i-differentiate mo muna siya with respect to y. Okay. Now, there are examples where yung function natin hindi continuous and this is not satisfied. So, pwede nyo na lang siyang i-search sa internet. Mahirap makahanap ng mga function na na hindi nagsasatisfy yung fxy equals fyx, and the failure is because of continuity. Okay. So, pwedeng maghanap na lang kayo sa internet ng example or kuha kayo ng higher math kung gusto niya. Okay. Usually naman for this course, halos lahat ng function na makukuha natin, mga simple function lang naman, yung mga polynomials, rationals, ln, exponential. Yung mga yun, pag kinuha nyo yung derivative nila twice, magiging continuous pa rin on their domain. So usually satisfied agad yung mga ganyan. Okay. So here's an example. Kunwari, may tanong. This is an example where Clairaut's theorem can be useful. Meron bang function, is there a function f whose partial derivative with respect to x is 3x plus 2y? Tapos yung partial derivative niya with respect to y is 4x plus 5y. Meron bang ganyang function? Question mark. Okay. So, ang sagot dyan ay wala. There's no such function kasi kapag tinignan niyo yung kung meron mang function na ganyan, ibig sabihin, kasi polynomial lang yung mga yun, di ba? So, fxy and fyx are continuous. So, sabi ng Clairaut's theorem, dapat equal daw yan. Okay. Pero, pag kinuha mo yung fxy, so that's the partial derivative of 3x plus 2y with respect to y. Pag kinuha mo yung fxy, ang makukuha mo ay 2. Okay. Pero pag kinuha mo yung fyx, so if you differentiate fy with respect to x, the derivative is 4. So hindi nag-equal. Continuous yung fxy tsaka fyx. So sabi pag continuous daw, dapat equal. So continuous sila pero hindi sila equal. Ibig sabihin may mali, no? Ibig sabihin walang ganung function. No? This cannot happen. Okay. Tapos syempre hindi lang naman second order, meron tayong third order derivatives, higher order derivatives, and it's the same. So you just so kunwari third order derivative, you just differentiate the second order derivative. Halimbawa, fxyx, that's a third order derivative kasi you're differentiating 3 times. Tapos paano mo i-interpret yan? Ang interpretation yan ay, you differentiate fxy. So ito yung fxy natin. You differentiate that with respect to x. Okay? So again, from left to right. Tapos halimbawa, in the partial notation symbol, from right to left naman. So kung meron kang partial cube u over partial x, partial z, partial y, ang ibig sabihin niya, i-differentiate mo muna siya with respect to y, and then with respect to z, and then with respect to x. Okay? And same with the second order derivatives case. Meron din tayong Clairaut's theorem for third or higher order partial derivatives. So halimbawa, you can check yung fxxy, fxyx, and fyxx. Magkakamukha lang yan. Hindi nagmamatter kung anong unahin mo. Basta mag-differentiate ka dalawang beses with respect to x saka isang beses with respect to y. No? Provided the functions are continuous. So kung continuous yan, mag-i-equal yung mga yan. Okay. So bigay lang tayo ng example just to show yung previous slide. Halimbawa, f of xyz is x times ln of 3y minus z. Pinapahanap tong f of zyx tsaka f of yxz. So unahin mo natin yung una. Okay. So f of zyx, ibig sabihin, kunin mo daw muna yung fz. Tapos pag nakuha mo ng fz, differentiate mo yan with respect to y. And then pag nakuha mo na yan, differentiate mo yan with respect to x. So one step at a time. Medyo nakakapagod. So derivative with respect to z. So that's going to be x over 3y minus z. Diba? Kasi ito constant, ito constant. So x over 3y minus z times, derivative ng 3y minus z with respect to z. So that's negative 1. Okay. So negative x over 3y minus z. Tapos, paano pag dinifferentiate niyan with respect to y? Kasi yun yung next na. Pag dinifferentiate niyan with respect to y, ang lalabas ay 3x over 3y minus z squared. So, iwan ko na lang sa inyo. You can verify. Yan yung makuha yung derivative. And finally, kapag dinifferentiate niyan with respect to x, so etong part na to, constant na lang yan with respect to x. Kapag dinifferentiate niyan, lalabas lang yung constant. 3 over 3y minus z squared. Kasi constant times a function of, constant times x lang yun. So, ang derivative niya with respect to x is just a constant. Okay? How about the second one? So, sa second one, unahin muna natin daw i-differentiate yung f with respect to y. So, pag ginawa mo yan, lalabas ay x over 3y minus z times 3. Kasi yung 3 ay derivative ng inside function with respect to y. Okay. Tapos, differentiate yan with respect to x. So, pag differentiate mo yan with respect to x, again, this is a constant times x. So, ang derivative ay 3 over 3y minus z. And then, I will just leave it to you kapag din-differentiate niyan with respect to z. So, yun yung huling variable din. Ang lalabas ay negative 3 over 3y minus z squared times chain rule, no? Derivative nito with respect to z, negative 1. So, ang lalabas ay 3 over 3y minus z squared. So, as you can see, parehas lang to. And again, the reason why they're the same is because of Clairaut's theorem. Kasi yung dinifferentiate natin yung function f natin with respect to x, with respect to y, and with respect to z. Pero magkaibang order lang. Hindi nagmamatter yung order kasi yung function naman natin ay continuous sa kanyang domain. Okay? So, that ends this video where the objective was to define and calculate higher order partial derivatives. Again, yung concept niyan should be simple. Kukunin mo lang yung partial derivative ng mga partial derivatives. Pwede lang sigurong kalituhan dito ay yung order ng pag-differentiate. Pero usually hindi nagmamatter because we have Clairaut's theorem. And this also ends the series of videos on partial derivatives and higher order derivatives.